Hi again. So we've gone through a lot of information about confidence intervals and how to get our standard error. So we're going to actually practice writing, calculating, and interpreting some confidence intervals with a bunch of examples here. Okay. So I've got the same formula box at the top, and remember this is for 95%, so I've got that in the title. That 2 has to do with the 95%. That's 2 standard deviations or 2 standard errors. Gets the middle 95% of the distribution. So here's an example. For each random sample, identify the point estimate. So we're going to be labeling whether it's a p-hat or an x-bar, a sample proportion or sample mean. Give the 95% confidence interval and write the interpretation of the confidence interval. Okay, so we're kind of putting it all together here. Sometimes we'll also need to find the standard error, and we did that in a couple of examples. So there actually will be given to us. Either the standard error or the margin of error will be given to us. Okay, so let's check out letter A here. A random sample of 80 cars. And if you like to just kind of label things as you go, that's fine too. I'm thinking, okay, n equals 80 there. Had an average fuel efficiency of 28 miles per gallon. Okay, so this is a quantitative, right, or numerical. 28 miles per gallon, and this is an average, so this is, I'm just going to write x bar. Provide a 95% confidence interval for the population mean. Here's another clue there. Population mean fuel efficiency with a margin of error of 3 miles per gallon. Okay, so this time we're given the margin of error, so we can use this top formula. And I'm going to write it out as x bar. Remember, either of these can be our point estimate. So I'm going to write it out as x bar plus or minus ME. That's the formula we're going to use. I just abbreviated margin of error. ME. Okay, so we know we have 28 miles per gallon plus or minus 3. And if you want, you can put miles per gallon MPG right there, or you can wait till the end. So then it's up to you if you want to show the plus and minus part, or I'm assuming that you can go right to the adding and subtracting. You can go right to the parentheses if you want, but I'm going to show it 28 minus 3 on my calculator, so that's 25, comma, 28 plus 3, or do it in your head, 31 miles per gallon. Okay, and then we're going to write out our interpretation. So remember what we did in the last video. So we're going to say we are 95% confident that the true mean fuel efficiency, so I'm going to put my variable in there. The true mean fuel efficiency, get all my I's and E's in there. We're 95% confident that the true mean fuel efficiency is between 25 miles per gallon and 31 miles per gallon, or you could just say 21 and 35 miles per gallon. Okay, now it doesn't have to be exactly that way, right? We saw there's a few variations in the last video, but we definitely need to have the confidence. We need to have either true mean, or we could also say, how else could we say that? The mean of all cars has a fuel efficiency, right? So we need either like a true mean or population mean or all, something referring to the population, right? As we're estimating our population mean. Okay, let's try another one. And you're welcome to pause the video and try this and then come back and check your work. A drug trial involved 300 patients, so N equals 300. We're not really using N in our formulas now, but remember that's in the standard error or margin of error that we're being given. With 90 of them experiencing a positive outcome. Okay, so positive versus negative, right? So this is a proportion. So we're going to have to calculate our proportion this time because they didn't give it to us in a percentage, they gave us a number. Determine a 95% confidence interval for the proportion of patients who responded positively to the drug with a margin of error of 0.09. Okay, say that 10 times fast. Proportion of patients who responded positively. Okay, can't believe I got it on the first try. Okay, so this time we have p hat. So I'm going to calculate it first. So here's where we do need n, because 90 out of 300, we need to know what that decimal is. 90 out of 300 is 0.3 or 30%. I'm going to write 0.30 just to keep the 2 digits. Okay, and now we can use our, let's check. Are we given the margin of error or the standard error? So here we're given the margin of error again. Margin of error. Up above I want to underline. We're given the, or circle even, we're given the margin of error. Here we're given the margin of error. So be careful which one you're given, right? So since I'm given the margin of error, I'm going to go p hat plus or minus me. Okay. And the margin of error is 0.09. So 0.30 plus or minus 0.09. Okay, do show your steps out like this because that's part of your work, and if something goes wrong, then I can help you, right? And I can give partial credit. So I think I can squeeze it in right under here. 0.3, oh, 39 is the higher one. See, I was trying to do it in my head, but I've got too many things going on at the same time here. Should be 0.21, right? 0.3 minus 0.09, yeah, 0.21, comma, 0.3 plus 0.09 should be 0.39. Okay, so 21 to 39%. We don't really need units if it's a proportion because these don't have units unless you change it to a percent. Then it would be 21 to 39%. So I might do that in my interpretation. So I'm going to start the same way. We are 95% confident that the true proportion of patients and I'm just copying the context here, the variable, true proportion of patients who responded positively to the drug is between 0.21 and 0.39. Okay, so because I said proportion, I'm going to keep it as 0.21 and 0.39. But if I had said percentage, then I could say 21 to 39%. Okay, 2 more. Letter C. In an election poll, 320 out of 800 randomly selected respondents indicated their intention to vote for candidate A. Provide a 95% confidence interval for the proportion of respondents supporting candidate A, given a standard error of 0.041. I've got to pause for just 1 second. Okay, I'm back. So let's see what information we were given here. So we've got 320 out of 800. So N is our 800. So this looks like a proportion again, right? Because we were given 320 out of 800. Sometimes they'll give us p hat, like they could have said up here, they could have said 30%. But so look for that. Sometimes they'll give you the percentage or proportion, and sometimes they'll give you the two numbers to divide. So this looks like a proportion again. So let's double check that. Yes, provide a 95 confidence interval for the proportion of respondents supporting candidate A. Okay, now this time we're given a standard error. Okay, so we're going to use that other formula. Okay, but we are given p hat, so I'm going to write p hat like I did the last time, but this time it's 320 out of 800. And let's see what that is. 40%, so 0.4 or 0.40. Okay. And then I'm going to write, because we're given the standard error, I'm going to write out this one right here, p hat plus or minus 2 standard errors. P hat plus or minus 2 SE, or 2.SE, either way. And we have 0.40 plus or minus 2 times parentheses 0.041. Okay, I'm going to go up above here and go 0.40 plus or minus and calculate this. 0.041 times 2, or 2 times 0.041 is 0.082. Okay, and now we're going to go ahead and calculate both of those. So I'm going to do the subtraction first. 0.4 minus 0.082 is 0.318, comma 0.4 plus 0.082 is 0.482. Okay, good. So let's write this one out. We are gosh, I keep doing that. We are 95% confident that, so let me see if I can write it in a little different way this time. 95% confident that respondents indicated their intention to vote for candidate A. They're not really telling us who our population is. Proportion of respondents. Okay, I don't like this wording actually. Confidence interval for the proportion of, I think we should say proportion of voters. It's because respondents is talking about our sample. So we're 95% confident that the proportion of voters, now we aren't quite given what our population is. Is it voters, likely voters, people who are registered? Sometimes it's likely voters. Proportion of voters who support or who intend to vote for candidate A. The proportion who tend to vote is 0.318 to 0.482. Okay. Or I could have changed it to percentage. We're confident that voters in the population who support candidate A is 31.8% to 48.2%, something like that. So there are some variations. It doesn't have to be exactly like mine. Okay, one more. Try it if you want, and then come back. The weights of 60 laptops chosen at random from a manufacturing facility were measured with an average weight of 2.5 kilograms. Provide a 95% confidence interval for the population mean laptop weight with a standard error of 0.12 kilograms. Okay, then we also have an extra question on this one. If the laptops are advertised as weighing 2.3 kilograms, is that a plausible value for the true mean? Okay, let's check it out. Okay, so first of all, is it p hat or x bar? That's the first thing to ask yourself. And I've seen average weight, and we have units, so that's another clue that it's numerical. So our x bar is 2.5 kilograms, right? We have our n equals 60. Okay, so, and are we given standard error or margin of error? That's the other thing to check. We're given standard error. So I'm going to use x bar plus or minus 2 standard errors. And then put in my numbers. So our average of our sample is 2.5 kilograms plus or minus 2 times our standard error of 0.12 kilograms. Okay, you can weigh your laptop after this and then convert it to kilograms. Unless you're used to kilograms already, which some people are. 2.5 plus or minus 2 times 0.12 should be 0.24, because 2 times 12 is 24, plus or minus 0.24, and then I'm going to go ahead and write it out here. So I need to save space for our other question as well. So 2.5 minus 0.24 is 2.26 kilograms. I also could put the kilograms in on each number in here. That would be fine too. 2.5 plus 0.24 is 2.74. So this is a little tighter, right? A little tighter interval. Okay, and let me put kilograms on there so I don't forget and think it's pounds or something else, right? Okay, let's go ahead and first let's write our interpretation, and then we'll answer this question, okay? So we are 95% confident that the true mean weight of all the laptops. So I said that one a little differently. So the true mean weight of all the laptops, but I'm still indicating that it's the population. True mean weight of all the laptops is between 2.26 and 2.74 kilograms. Okay, great. So now let's look at our other question. If the laptops are advertised as weighing 2.3 kilograms, is that a plausible value for the true mean? Okay, so the advertised value of 2.3, let's check. Where would that be? It is in our interval, right? And remember, a confidence interval is a range of plausible values for the population parameter. So yes, that is a plausible value. So let's write that out. The advertised let me say weight, be more specific. The advertised weight of 2.3 kilograms is in the interval. So it is a plausible value for the true mean. Okay, Now, if they said our laptops are 2 kilograms, then I don't know about that because it's only going down to 2.26, but 2.3 in our interval. Okay, hope that gives you lots of good examples to practice with, and I'll see you in the next video.